Somebody had a question.
May I grab paper I ran on the pages? In my math binder.
If you go back to our way back sheets here, when you have a graph, we have what are called the domain and the range. And if you remember, back in the day, let's say I've got this linear equation, y equals 2x plus 1. You can take and make a table out of that. Let's say x is negative 1, 0, 1, and 2. If I put negative 1 in for x, 2 times negative 1 is negative 2 plus 1 is negative 1. 0 gives me positive 1, 1 gives me 3, 2 gives me 5, right? I'm just going fast because you should know all that, right? If you remember back in the day, when we talked about these sort of function sort of things, we said that the x values were what were also called the domain numbers. They were the input numbers. And the y values were the ones that we called the range numbers. Okay? If I graphed it, it looked like this. The graph of that looked like what? Remember graphing by slope-intercept? What? Crosses the y-axis here, has a slope of? I'm waiting for somebody to say. Slope of? 2, thank you very much. Okay, so you got that linear equation there. What we're talking about today is people will ask you to state, or they'll say, what is the domain and what is the range? And when they're asking you that question, they are asking you, the domain is what can x be, and the range is what can y be. What numbers can they be? And linear equations are a little bit on the different side simply because what you're asking is, you know, what number can I put in for x? And we do it like this. The domain is, and we'll make a set of numbers. And the range is, we have a set of numbers. Well, if you look at the x, by the way, children, take a look-see. This is the x-axis. This is what all the x's can be here. What can't x be? Knowing that these arrows mean that these lines go on forever that way and forever this way. Is there anything that x can't be? In other words, if I pick this point right here, what is x at this point? X is 1, 2, 3, 4, 5 something. A negative 5 something. Or what is x over there? Savage, any idea? Shoot me at something here. Give me just a general idea.
It can be any.
Thank you very much. When it is a linear equation, when it is a line, because x goes, these arrows mean this goes on forever and ever, the domain for x, which are the x values, is all real numbers, which we throw this little r out there, or whatever that thing is. All real numbers. X can be anything. What can the range be? Westfall, pick up on what we just laid in. Thank you very much. On a straight line, both the domain and the range can be any number. But that is not always the case. Little dramatic drum roll there. Good. If you look at that piece of paper I gave you, did I give you this piece of paper that has this on here?
Yes.
Okay, if you look at this piece of paper right here, Well, let's make this big here. This graph is not all real numbers because it has an endpoint and an endpoint. Okay? So you can't put all real numbers here. So the question is, for this, what is the domain? Well, if it has, where'd my thing go here? It's a little big here. Okay, when you look at the domain, you are looking for what x can be. And a good way to think about this is think about making a box. All right, well, think about taking the line that you have and putting it inside of a box. I would go across to here, across to here, across to here, and across to here. Okay. If it has a beginning and an end, that means x also has a beginning and an end. And it's pretty simple here. I put my x in the middle. This is one of those compound inequality kind of things. Okay. What is the smallest x can be? Well, it goes all the way to this point right here. What is x at this point right here? You'd have to figure it out. -1, -2, -3, -4, -5, -6, -7. That's the smallest it can be. Correct? And then you have to look to see, is it a colored in dot? If it's a colored in dot, that means it can equal -7. X has to be greater than or equal to -7. And then on the other side of x, you put what's the biggest x can be. X can be 1, 2, 3, 4, 5. But it can't equal 5 because it's an open circle. So this is my domain. X can go anywhere from -7 to +5. If it's colored in, there's an equal sign. If it's not colored in, it's this. Always, 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 your inequalities are going to be that less than sign. And then the same thing is true for the range. The range are the y values. And you think about what's the smallest y value you can have? What's the lowest this goes? What is this point right here? Help me out here, people. Faith. What is y at this point?
4, 3, I can't.
-1, -2, -3. Right? Aren't you on
Yeah,
the
so
same
I was
page?
looking back in inequalities with the circle.
Okay. And you get the same thing. It has to be the less than, it's colored in, so it's equal to. And what's the biggest y can be? What is it at this point right here?
2.
1. It's 1 up. And it doesn't equal that, so it's that. So this, ladies and gentlemen, is your domain and your range. Look at, did I get it right? Oh look, there it is. I think I got the range there. It's the small, what x is from its smallest to its biggest, and what y is from its smallest to its biggest. Voila and voila. Let's look at another one. The more you do this kind of, the better it gets here. Or is there a second one here? I think there is. Is this one? Now, so we've done 2 so far. One was a line that goes on forever, up and down and sideways. This one here had one endpoint, another endpoint. Look at this one. This one has a starting point, but no stopping point. What in the world? How is that? How are we going to show that with our domain and range? So let's think about that. Here's my domain, and here is my range. Domain is what? X values. All right. Well, my x on my x-axis, where does it start? It starts right here, correct? Where does it end? Look at Savage, come on, yeah. This arrow means it's going to go forever to the right, but it does have a starting point. How do I show that in an inequality? What can x be? X has to be what? X has to be anything greater than 0. X must be, it starts here at 0, greater than or equal to 0. Correct? Because it starts at 0, goes forever that way. What about my range? Y must be, is there a stopping point for y? Starts here, correct? Where will it top out? Never. It's gonna narrow out, but it's just gonna keep going for that way. So how do I say that? Y has to be
Greater than or equal to 0.
greater than or equal to 0, same thing. It starts here, it goes forever that way. It's going to go forever up and forever out, but it doesn't go forever backwards. It starts right there. So there's my domain and my range there. Oh, the kids are getting better. It takes a little time here. And then the last one, there was one more, right? Let's take a look at this one. Oh, wait, what is this? Let's try this one. What is my domain and what is my range going to be here? Think about the x values. Again, knowing that these arrows mean it goes on forever that way and goes on forever that way. Who thinks they know what the domain is? What can x be? Somebody out there. Parker. Where does x start? Where does x stop? Thinking about the x-axis, these numbers here. How far does it go this way? How far? Where does it start on the left side? Where does it end on the right side?
Never.
Never. So what's my domain? Look at the first graph we did. The first graph was an example of it never starting and stopping. The domain would be
0.
no,
Real numbers.
all real numbers. 0. If the domain was 0, it just means that dot right there at 0. The domain is all real numbers. Now that's not true for the range. Why? Is there a starting point on the y?
Yes.
Y starts right here, but goes forever up. Which means, Abram, it's going to be
Range equals R is greater than.
no, it's not R. It's not R means all real numbers.
Sorry, Y equals.
Yeah, Y equals.
Greater than or equal to 0.
Yeah, Y has to be greater than or equal to 0 because it starts here where Y is 0 and goes forever up. So those are your domains and your ranges. Whew. Is there something else on all this? Oh yeah. So here we go. Let's take a look at this. Interesting graph as it would be if I asked you to give both the domain and the range of letter A. Again, my best way I've always thought is think about it in a box. If you drew a box around the whole thing, the highest the box gets is this. The lowest the box gets is this. The farthest right the box goes is here. The farthest left the box goes is there. Isn't that exciting? So my box actually is, the whole graph is contained in this little green section here. So if I were to ask you what the domain is where it starts on the left to where it goes on the right. That's one of those compound inequalities with x in the middle. What's the smallest value of x?
-6.
-1, -2, -3, -4, -5, -6. Can it be equal to -6? Yes. So you do this. And what's the highest value it can be? 1, 2, 3, 4, 5, 6 there. So can it be equal to that? Yes. So that is my domain. How about my range? Carter Westfall, what's the smallest y can be? What's the lowest it goes?
Is negative, +3.
The axis is right here.
Oh.
Is it not? Is that the axis? I think it is.
Mm,
What is y right here?
up and down. Oh,
This isn't the axis, is it? My pen. Oh yeah, no, I'm right, yeah. What's the smallest y can be? What is y right there? Y goes from here to here. What is this? 0. This is the y-axis right here. Or the x-axis. Right there, y is 0. -1, -2, -3, positive 1. So it goes from 0. Can it be equal to 0?
yes.
Yep. All the way up to what?
7.
1, 2, 3, 4, 5, 6. Catch me on that? If it has a starting and a stopping point, you're going to get a compound inequality like that. If it has an arrow on it, you're probably going to get, if it has 2 arrows on it, it's going to be all real numbers for something. If it only has 1 arrow, it's going to go somewhere. Letter B, you give me the domain and range for letter B. You tell me what you think the domain and the range for letter B are. Domain equals the range equals. I'm guessing it's going to have an x and a y in the middle of it. X and Y. This is my report the day been so far.
Can't complain, how about for you?
Oh, I should complain, but I won't.
Oh, good.
Missing kids, look at them, down 3.
What's that?
I'm missing 3 kids, we're down
3
9.
kids.
Oh, we can never play hockey because there's never enough for a team.
You do the thing we did last time.
3 on 3 on 3?
No, yeah.
We should totally do that.
Yes.
3 on 3 on 3. Who tends to what goal? We need a third goal.
We don't-
No,
We have a
whoever
third
scores in, like, then they switch or something like that. Did we do that last time?
Yeah, I
What do we
bet
get
you-
for
I-
Gawain and Regis? Westfall, quit trying to get me off track here.
Okay.
Again, thinking, here is the lowest x's, there's the highest x's, here's the lowest y's, that's the highest y's. So box in that line. What is my x values? Goss, x has to be what?
-7.
Greater than -7, is it greater than or equal to, or just greater than?
Greater
Yep, greater or equal to -7, it goes all the way to what?
than 5.
What'd you say?
5.
5. Can it be equal to 5?
No.
No, so it's just that. There's my domain, and you should put the little brackets around that, because that's just the way it looks. How about y? Who wants to speculate on y, Brant? What's the smallest y can be? Very good. Can it equal -3?
Yes.
And what's the highest y can be?
1.
1. Can it equal 1?
No.
No. Shebang. Somebody good with that? And give me another one. Ooh, this one. This is snarky. What do you think about that one? Think about the box there. What's my domain? What's my range? By the way, there is a domain and there is a range. It's a mighty narrow box, let's say, width-wise or height. It's got some height to it though. Domain, range, x, y. Who's got my x? Guess what the domain is? Jacob Licht, what do you think the domain is?
-5.
And that's it, right? Yeah, x just is right here. X actually equals -5. That's all you can do, because that's what it is. The domain is x equals 5. Now the range, it does go from bottom to the top. What is y there? -2. And it goes all the way up to 1, 2, 3, 4, 5, 6. Kind of get some sort of a, what do you think? Doable? I guess it don't matter. What I have for you children is this.